Hi guys, hello everybody, क्या हाल चाल है भाई, namaste, and this is Saurav Goswami on the Vedantu Catalysis channel, welcoming you all at this early morning on another lecture of coordination compounds. How are you guys doing? How are you guys doing? Please say yes if I am audible and visible and everything is fine at your end. Good morning everybody. Good morning Ishu, Nicola, Sujita, Sri Balaji, Ashwin, Ishu, Hare Krishnan, Tarun, Arati, Shubhodaya, Ashwin, Gurjot, Tarun, Sai, Tarun, Chakilam, Tejashwini. Very nice to see you guys here. This is the first week, so maybe like if I spend time over here, I'll get to know the names of you guys as well. So the moment we start you identifying the names, that relationship starts building. So give it some time. It will take a while to get used to the new names. Okay, good morning everybody. Good morning. And chalo. So today's agenda is, in yesterday's class we had discussed something related to Werner's theory. We had started discussing about what coordination compounds, why should we study coordination compounds, and what is the purpose that we are trying to solve. And I had told you that coordination compounds topic is not a very old science. Okay, coordination compounds topic is not a very old science. It started sometimes in the late 19th century, that is 1800 something, and it's fairly new. A lot of work actually happens in coordination compounds these days. In fact, when I did my master's thesis, my thesis was exactly on coordination compounds. I did work on vanadium, oxo-vanadium complexes. Anyways, that's all about me. Let's start our discussion for today. Our discussion for today is around a bit of Werner's theory, and we will try to learn the vocabulary of coordination compounds as well. So I'd request you guys to sit with a pen and a paper, take running notes, take snapshots, whatever you can, but at least be in sync with me. Okay, at least be in sync with me. So chalo, let's move ahead. Yep, just a moment. Okay, I guess if you recall, we had how many lectures for this topic? We have just started, man. We just started. So let's start studying. Okay, stop worrying for that as of now. So we had discussed this yesterday. If you recall, we had discussed this yesterday, that Werner's theory is something which started with the idea that we had expected a certain number of precipitates out of cobalt, ammonia, chlorine complexes, but we were getting a different number of precipitate. As from COCl3.6NH3 we got 3 moles of precipitate. From COCl3.5NH3 we got 2 moles of precipitate of AgCl, and with COCl3.4NH3 we got 1 mole of precipitate. Okay, see, my voice is not coming. My voice should be coming, man. My voice should be coming. Okay, this was experiment 1. Please check the internet connection at your end. If my voice is not coming, my voice should be coming. Everything is fine at my end. Okay, so chalo, let's start discussing even further. So if I recall correctly, we had discussed that there were 3 Werner complexes: COCl3.6NH3, COCl3. Okay, COCl3.5NH3, COCl3.4NH3. Okay, and this was giving 3 moles of precipitate of AgCl. This was giving 2 moles of precipitate of AgCl, and this was giving 1 mole of precipitate of AgCl. with AgNO3. This was the amount of precipitate which was obtained. Now let's go on to experiment 2. Experiment 2 was about measuring the molar conductance. Okay. Experiment 2 was about measuring molar conductance. Now, what is molar conductance? What is molar conductance? Molar conductance of a solution is proportional to the number of ions. Molar conductance of a solution is proportional to the number of ions which are present in the solution. Okay. Akanksha, it is not important that the year in which Werner started working. Point is, at that point of time, the instrumentation abilities were so less that Werner giving this theory is itself a miracle. Okay, so let's focus on the experiments. So experiment 2 was about molar conductance. When you take molar conductance, you will see that when you measure molar conductance, conductance is the ability to transport charge. It depends on the number of ions. If I take sodium chloride and I take magnesium chloride, the number of ions produced over here is 2 and the number of ions produced over here is 3. So if I look at the molar conductance, then can you tell me which one will have higher molar conductance? Which one will have higher molar conductance between NaCl and MgCl2? Please tell me in the chat box which one will have higher molar conductance. MgCl2. Very good, Ajita. Very good, Ajita. The higher molar conductance will reside with MgCl2 because it produces more ions. It produces 1 Mg2 plus and 2 Cl minus. So this is higher. Similarly, what Werner expected is COCl3 dot 6NH3 COCl3 dot 5NH3 COCl3 dot 4NH3. Now you can see that there is one cobalt, and there are 3 chlorine atoms. 1 cobalt, 3 chlorine. So what Werner expected is the same value of molar conductance, because if I have 1 cobalt and 3 chloride ions, then I would expect that there would be 4 ions which will be produced. Hello Partha. Okay, it would be expected that there would be 4 ions which will be produced. So he expected that there would be 4 ions which will be obtained. So he expected that molar conductance, expected number of ions was 4 because 1 cobalt, 3 chloride. Okay, 1 cobalt, 3 chloride. If I take an aqueous solution of cobalt chloride dot 6NH3, 5NH3, 4NH3, then I should be expecting 4 ions obtained from everything. However, the molar and I should be expecting alike value of molar conductance. If the number of ions are alike, then the molar conductance should be alike. But what was happening is that the molar conductance was highest for this and was lowest for this. Okay, the highest for this and lowest for this. It meant that there are more ions produced from COCl3.6NH3 and less from COCl3.4NH3. 6NH3 is producing more ions, 4NH3 is producing less ions. Werner later on identified that COCl3.6NH3 produces in fact 4 ions, while COCl3.4NH3 produces how many ions? It produces, if I'm not mistaken, it produces 2 ions. But how? Why it is producing, first one is producing 4 ions and the last one is producing only 2 ions. Okay, last one is producing only 2 ions. So from here Werner tried to give an idea. So he did these 2 experiments. Apart from this, he did some other experiments related to Van 't Hoff factor, depression, freezing point, elevation, boiling point, but they are indirectly related to the number of ions only. Okay, so if you look at Van 't Hoff factor, it depends on number of ions. If you look at elevation and boiling point, it depends on number of ions. Okay, and if you look at depression, freezing point, it also depends on number of ions. All of these things depend on number of ions. So experiment 2 leads to various conclusions, and they were substantiated with this idea that how many ions are obtained. Multiple experiments were done to identify. Yeah, I will do that, Aniket. Yes, you can solve VQuiz, not VQuiz as well. Yeah, you can solve VQuiz as well. In fact, you should solve VQuiz as well. I bet you will be able to solve VQuiz as well utilizing this lecture. Okay. Yes. So now what Werner suggested, Werner gave a very radical idea. Okay. Werner gave a very radical idea. What Werner suggested is this. Usually we think that all metal and non-metallic species will come out in the solution, but it is not the case with coordination compounds. He suggested that in complexes, all ions, I mean to say cation and anions, do not come out in the solution. Out in the solution. What comes out in the solution? So the anions. So there is a cation, the anions, which are bound by covalent bonds. They are unionized. They are unionized. And whatever is bound by ionic bonds, they are ionized. Okay, they are ionized. Understood? S. Rahman, please stay with us. You will be able to understand things. So do you understand? Like in CCl4, there are 4 chloride units. But all chlorine atoms, this CCl4 does not give chloride ions in the medium, because they are connected by covalent bonds. But sodium chloride, magnesium chloride will give chloride ions in the medium because they are connected by ionic bonds. So remember, Werner said this, I gave this idea that there are some chloride ions which are connected by covalent bonds and some chloride ions which are connected by ionic bonds. The ones which are coming out in the solution are connected by ionic bonds. The ones which are not coming out in the solution are connected by covalent bonds. Is that clear? Is that clear? Please tell me, is that understood? that the ions which are coming out in the chloride ions which are coming out in the solution are connected, or ionized ones are connected by ionic bonds, and the ones which are unionized are connected by covalent bonds. Okay, so let's extrapolate this idea. Let's extrapolate this idea and see what we can say. So Werner said something. Werner gave certain postulates. Okay, Werner gave certain postulates. So Werner said that this. If you look at all the cobalt ammonia complexes, then he said that COCl3.6NH3, since is giving 3 moles of precipitate of AgCl, should have 3 chloride ions which are ionized. 3 chloride ions which are ionized. So the part which is unionized will be represented within square brackets. So I will write it like this. Is that understood? The part which is ionized will be represented outside the square bracket. The part which is unionized will be represented inside the square bracket. Clear? The part which is ionized outside the square bracket, the part which is, so the square bracket is like kind of a cage. Anything inside it will not undergo ionization. Everything outside it will undergo ionization. Okay. Similarly, if I take COCl3.6NH3, I am getting 2 moles of precipitate of AgCl, which means 2 chloride ions should be outside. Okay, sorry, COCl3.5, this should be 5. 5NH3. So 2 chloride ions are outside because I'm getting 2 moles of precipitate, and everything else is inside. CONH35Cl. Okay, CONH35Cl. Next, COCl3.4NH3. How many moles of chloride ion precipitate, how many moles of AgCl precipitate are we getting? We are getting a precipitate of 1 chloride ion, and everything else is inside. Everything else is inside. Is that understood? So whatever number of moles of precipitate of COCl3.5NH3, number of moles of precipitate of AgCl is obtained from each of these complexes, that many chlorines are outside the cage, and whatever is not undergoing ionization is present inside the cage. Werner later on gave a very, very amazing idea. He gave an amazing idea. He suggested that every metal, so he said that when you write this complex CONH3,6Cl3, he suggested that this will be known as the central metal atom, or you can call it central metal ion. You can call it central metal ion. And central metal ion has 2 types of valencies. Okay, it has 2 types of valencies. On the basis of this, he said that it has 2 types of valencies. First one is primary valency, which is 1 degree valency. Okay, so how can we know how many? Just by looking at the complex, beta. By doing the experiment, you will be able to identify how many ions are precipitated. So by looking at these things, by looking at multiple experiments, you can make that judgment. Later on, you will understand by looking at the way a complex is represented, you can identify how many ions can be obtained. Primary and secondary. Secondary valency. It is written as 2 degree. So primary valency, remember, primary valency is ionizable and secondary valency is non-ionizable. This was the earlier idea. In fact, yes, it is important that you read NCERT after my lectures, because then you will be able to understand things in like the more perfect manner. ठीक है, सबसे अच्छे तरीके से आप समझोगे. So ionizable and non-ionizable. So please try and understand that this was an earlier idea. Later on, Werner modified the ionizable idea to oxidation state of central metal atom. He said that the primary valency is nothing but the oxidation state of the central metal atom, and the secondary valency is whatever present inside the square bracket. Present inside square bracket. Okay, present inside a square bracket. Okay. How would we say that 3 are under covalent bond or ionic bond? So Amulya, if you look at the first complex, you are seeing that 3 chloride ions are coming out. So 3 chloride ions must be connected by ionic bonds. In the second experiment, 2 chloride ions are coming out of 3. So 2 chloride ions are giving the precipitate of AgCl. So 2 chloride ions must be connected by ionic bond, and one of them will be connected by covalent bond. The number of precipitates, the number of moles of precipitate of AgCl gives us the number of ionic and the number of chloride ions connected by ionic bonds. Whatever is not getting precipitated is connected by covalent bonds. Okay, I hope this is clear. I hope this is understood. Okay, I hope this is understood. Clear? If you want to take a note or a screenshot, you can go ahead and do that. I hope this is clear. Okay, chalo. So So let's look at Werner's postulates. So in coordination compounds, there are 2 types of linkages or valencies, primary and secondary. I have made, so they are written properly. Okay. In coordination compounds, metals will show 2 types of linkages, primary and secondary valency. The primary valency are normally ionizable and are satisfied by negative ions, and the secondary valencies are non-ionizable. Secondary valencies are non-ionizable. They are satisfied by neutral atoms, or so secondary valency is equal to the coordination. So let's identify something. So if I start with COCl3 dot 6NH3, number of moles of precipitate of AgCl is 3 moles of precipitate of AgCl. So the representation, okay, yes, Shivam, you can do that. The representation of the compound will be this CONH3 6Cl3. Whatever is present outside the square bracket will be ionized. So if I want to write the primary valency and the secondary valency in this case, primary valency and secondary valency in this case. In the first one, let's say this is the first one. In the first one, if I want to write the primary valency, so 1 degree valency and 2 degree valency. So 1 degree valency is the oxidation state of cobalt. Okay, 1 degree valency is the oxidation state of cobalt. So 1 degree valency is equal to plus 3. Can I say that 1 degree valency is 3, because you can write plus 3 or you can just write 3. And 2 degree valency, which is the one which is present inside the square bracket. Okay, 2 degree valency is present inside the square bracket apart from the metal. So except for the metal, whatever is present inside the square bracket will contribute to the 2 degree valency. So that is equal to 6. Okay, that is equal to 6. Is this understood? Please tell me a yes or no. Please tell me a yes or a no. This is understood. The oxidation state. So oxidation state of central metal atom, and this is whatever else is present inside the square bracket except the central metal atom. Okay, present in square bracket is the secondary valency. Very good, Naitik. Very, very nice. I saw you in my class yesterday. 1 degree valency and 2 degree valency. 1 degree valency and 2 degree valency for the second compound COCl3.5NH3, whose representation was, it was giving 2 moles of precipitate of AgCl, and the representation was CONH3 5ClCl2. The representation, with this representation, the 1 degree valency oxidation state is not changing, so it will be 3, and the number of species inside the square bracket apart from cobalt is 6. Okay, so 1 degree valency and 2 degree valency remain constant. Okay, 2 and 6. Second degree valency is the other species present inside the square bracket apart from the metal. So this is the metal. Excluding the metal, whatever is present inside the square bracket is present inside the square bracket is the secondary valency. Okay, this is written incorrectly. The primary valency is 3. Okay, the primary valency is 3. And if I take COCl3.4NH3, for this, moles of precipitate of AgCl is 1, and representation will be CONH3 4Cl2 Cl. Okay, oxidation state of nitrogen, you do not have to calculate the oxidation state of nitrogen. You can always need to calculate the oxidation state of the metal. You can calculate oxidation state of nitrogen nevertheless, but it is not needed. NH3, it will be -3. Oxidation state will be -3. 1 degree valency will be 3. Again, 2 degree valency will be 6. So the 1 degree valency and the 2 degree valency remains constant. Can you see this? The 1 degree valency and the 2 degree valency remains constant. Okay, 1 degree valency and the 2 degree valency remains constant. There's absolutely no change. How do you represent them? How do you represent? Okay, very good. Yes, Superman said coordination number. Okay, so it's not a reaction. This is the number of moles of precipitate of AgCl. That's not a reaction. So how do you make this representation? How do we make this representation? Let's go ahead. Let's see this. So remember that if I look at the primary valency, then the primary valency is shown by a dotted line. Dotted line. And the secondary valency is shown by a thick line like this. Okay? It is shown by a thick line like this. So, if I pick COCl3 dot 6NH3, the primary valency, 1 degree valency is 3, 2 degree valency is 6. So how would I represent this? How would I represent this? So look over here. Can you tell me the oxidation state is because of which of these species between chlorine and ammonia? Between chlorine and ammonia, what is responsible for assignment of oxidation state? It is chloride. Chloride has oxidation state of -1. Each chloride has oxidation state of -1. So 3 chloride, because of which cobalt gets +3 oxidation state. So if I were to represent this, then I will represent NH3 in whatever fashion I can. So 1, 2, 3, 4, 5, and you can put 1 NH3 over here as well. Okay. How to calculate oxidation state? Oxidation state is very easy, na? If this is X, this will be -3, this will be 0, ammonia is 0, and the total oxidation state is the total charge, which is equal to 0. So the oxidation state is +3. So the dotted lines will be shown with chlorine. Dotted lines will be shown with chlorine. Dotted lines will be shown with chlorine. Is that clear? Dotted lines will be shown with chlorine. Is that understood? Dotted lines will be shown with chloride. Is that understood? So remember, whatever is responsible for assignment of oxidation state on the central metal atom will be shown by dotted lines. Everything else will be shown by bold lines. Okay? Clear? Please tell me yes in the chat box. If this is clear, please tell me a yes in the chat box. Yes? How to calculate? I just showed you how to calculate oxidation state. Oxidation state is something that you have calculated earlier as well. Now let's look at the complex. This COCl3, I've just showed you. Okay. Dotted lines dotted lines will definitely represent ionic bond, but there is a small variation. So COCl3 dot 5 NH3, COCl3 NH3. The representation of this complex is CONH3 5 Cl Cl2. Okay, clear? Dotted line. Why dotted line for Cl? What is responsible for oxidation state of cobalt? What is responsible for the oxidation state of cobalt? Cl is responsible for oxidation state of cobalt. 1 degree valency is the oxidation state. What is responsible for it? Cl. So every Cl is shown by dotted lines. Cobalt has +3 oxidation state, and so each chloride will be shown by dotted lines. Each chloride will be shown by dotted lines. You can draw it in any way possible. Each ammonia will be shown by bold lines. Each ammonia will be shown by bold lines. Now there are 5 ammonia. Now but there is one. Okay, you can see that there is a chloride which is also inside the square bracket. So you will show one of the chloride with dotted line as well as bold line, because this chloride which is inside the square bracket is responsible for assignment of oxidation state of cobalt. Also, since it is present inside the square bracket, I will call it secondary valency. Okay, is that clear? Is that understood? No, all chloride ions are not getting ionized. No? Only these two chloride ions are getting ionized. If you follow properly, you'll be able to understand. Suppose the example is this. CO, there is Cl, and this is the example. COCl H2O5 Cl2. So what is the oxidation state? What is the oxidation state of cobalt? Oxidation state of cobalt is +3. So I will represent all chloride with plus dotted lines, but I can see that within the square bracket there are 5 H2O and 1 chlorine, so I will represent 5 H2O with bold lines. Also one of the chlorine atoms with one of the chloride ions with a bold line as well. Cobalt oxidation state is not 2, man. Cobalt oxidation state is +3. Where did I write 2? I have not written 2 anywhere. It is +3. Okay, it is +3. Clear? Chalo. Is this understood? This is all about Werner's theory. Werner theory has told you primary valency, it has told you secondary valency, it has showed you what are the dotted lines, what are the non-dotted lines. What do dotted lines mean? What do non-dotted lines mean? What does dotted plus non-dotted dotted plus bold line means? Okay, that is what it shows. That is what it shows. Let me ask you a question. Let me ask you a question. Okay, let me ask you a question. Question is this. Suppose a complex A is shown as A Suppose a complex is shown like this. Al5 Br2. Al5 Br2, where A is the central metal atom. Then is this the right representation? And this ligand, sorry, let me just use a simpler representation so that it will not be confusing for you guys. Okay, suppose there is a metal, there is H2O, there is H2O4 Br2Cl. Okay, H2O4 Br2Cl. So is this the right representation of this Werner complex? H2O, 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 Br, Cl. Is this the right representation? I will explain the type of ligands a little later. Is this the right representation of this compound? Is this the right representation of this compound? Or there is some other representation? Yes, Akanksha. Yes, Akanksha. Is this the right representation of this compound? Think. Is this the right representation of this compound? There is a dotted line. If let me just draw it again. There is a dotted line. If you cannot see it, I am gonna represent it again. There is a dotted line over here. Okay. Both the BR should be thick and thin line. Very good, guys. Very good. Very, very good. Both the Br should be with thick and thin line. So metal H2O with thick line, 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 Br with dotted line, Br with dotted line, Cl with dotted line, and the two Br also with thick line. This should be the representation. Oxidation state is +3, man. Like, this is something that you have read in 10th standard, like 11th standard beginning. Please revise that. Okay, this is the right representation. That, like, if metal is present in the center, then this should be the situation. Okay, yeah, you can do JD Lee. There is absolutely no problem. Okay, I hope this is clear. So Werner theory is done and dusted. Werner theory is done and dusted. Okay, Werner theory is done and dusted. Clear? Chalo, let's take this question. Let's take this question. Please try to look at the question. The complex COCl3.5NH3 in aqueous solution ionizes to give a total number of ions equal to. What is the right answer? What is the right answer? Br2 does not have zero oxidation state, Gurjot. Each Br, it is bromide, man. Each Br has an oxidation state of -1. Okay, each Br has an oxidation state of -1. So what is the right answer to this question? A complex COCl3.5NH3 in aqueous solution ionizes to give total number of ions equal to. What is the right answer? What is the right answer? Somebody saying 2, somebody saying 3. It's very simple. COCl3.5NH3 will be represented as like this: CONH35 Cl2, and so the number of ions that I will be obtaining will be COCl NH35 2 plus 2 Cl minus, which make up a total of 3 ions. Which make up a total of 3 ions. Guys, can you see this? There are a total number of ions will include cation as well as anion. Total number of ions will include cations as well as anions. So there will be a total of 3 ions. It's a very simple question. Very, very simple question. Clear? Answer is 3. Answer is 3. Congratulations to everybody who got the right answer. Answer is 3. Okay, let's look at this one. Which of the following is non-conducting of electricity, or which is a non-conductor of electricity? Which of these will be a non-conductor of electricity? Think that what would be the structure of these respective complexes. Will they be giving ions? If they are giving ions, how many ions are they giving? Will they not be giving ions? And if not, then which of them will be the correct? Okay. The right answer is Akanksha correct, Bhanu Prakash correct, Shubhajit Mandal correct, Shubhodaya correct, Gurjot correct, Ashwin correct. Everybody who has answered it as D is correct. Everybody who has answered it as D is correct. Because CONH3 Cl3 will be the arrangement. Okay. Okay, Rahman, you will have to watch the lecture once again, beta. I cannot go back. Okay, let's focus on the right. So please do remember that whatever number of species are present in the square bracket apart from the metal, they are known as the coordination number. Coordination number. Coordination number is equal to the secondary valency. I hope this is clear. Okay, the right answer is D. The right answer is D. So because in this case we will have a total of 2 ions, this will give a total of 3 ions, this will give a total of 4 ions, and this will give a total of 0 ions. Very nice, guys. Very nice. You will always try to preserve the secondary valency. So cobalt has a secondary valency of 6. First you will assign that 6, and then whatever is left out you will put outside the square bracket. Okay, chalo. Very good. Okay, let's look at this question. When AgNO3 is added to a solution of CONH3 5Cl3, the precipitate of AgCl shows 2 ionizable chloride ions. This means, what does this mean? 2 chloride ions satisfy primary valency and 1 chloride atom satisfies primary as well as secondary. 1 chloride ion satisfies secondary valency, 2 chloride ions satisfy secondary valency, 3 chloride atoms satisfy secondary valency. What is the right answer to this question? Please look. Okay, what is the right answer to this question? Which is the right answer to this question? Please tell me the right answer. One degree Amulya, no. 1 degree valency is 3, but number of ions produced is 0. The right answer to this question, my dear students, has been given by Akanksha Shivam. Shivam has made a mistake. Hari Krishnan. Okay, SK Imran, David Gilmore. Okay, the right answer is A. The right answer is A. COCl3 NH3 5. So CONH3 5 Cl2. So primary valency is 3, which is fulfilled by 3 Cl minus. Secondary valency is 6, which is fulfilled by 5 NH3, 5 NH3 units and 1 Cl. So 2 chlorine atoms satisfy primary valency, and 1 chlorine atom satisfies both primary as well as secondary valency. Very good, Gurjo. Very good. Okay, very nice. Next question is this. This is slightly challenging. This could be slightly challenging. So let's look at the question. Slightly looks a little scary. You have to read more. Okay, you have to read more in this question. So let's look at the question. A coordination complex of a cobalt has a molecular formula containing 5 ammonia molecules, 1 nitro group and 2 chlorine atoms for 1 cobalt atom. Okay, so 5 ammonia, 1 nitro, 2 chlorine. Okay, 1 mole of this compound produces 3 mole ions in aqueous solution. Clear? 3 moles ions means 3 ions are produced. In reacting this solution with excess silver nitrate, 2 moles of AgCl gets precipitated. Amazing question. The right answer is Shaolin Legends has already given the right answer. Adi has given the right answer. Balaji has given the right answer. The right answer, guys, is C. The right answer is C. The right answer is C. Shivam has also given the right answer. Amulya has given the right answer. The right answer is C. How do we explain this question? So there are 5 ammonia molecules, 1 nitro and 2 chlorine. 5 ammonia, 1 nitro, 2 chlorine. 1 mole of this compound produces 3 ions. Yes, this will produce 3 ions. It will produce CONH3 5 NO2, which will remain unionized. So plus 2 Cl minus. So there will be 3 ions which will be produced. Hello Tarun. Okay, 3 ions from the complex. And how many moles of AgCl get precipitated? We have 2 moles of AgCl minus. So I'll get 2 moles of AgCl which will get precipitated. Okay, 2 moles of AgCl which will get precipitated. I hope you have understood Werner theory completely. I hope you have understood Werner theory completely. Okay, so if you give some time, so everything demands some amount of dedicated effort. Okay, some amount of dedicated effort. Once you put that dedicated effort of that duration, you will get the result. Obviously, you'll get the result. Okay, yes, chalo, lovely. Thank you, Shri Balaji. Give the answer to this question. Give the correct increasing order of electrical conductivity in aqueous solution of the following complex species. Okay. Okay. So give the correct increasing order of electrical conductivity of aqueous solution of these following complex entities. You have to identify that which will conduct electricity to the maximum extent. Now conduction of electricity, students, is dependent on the number of ions. Conduction of electricity is dependent on the number of ions. It is dependent on number of ions. If it is dependent on number of ions, then what will be the right answer? The maximum number of ions are produced by 1, followed by 2, followed by K2 plus 1, 3 plus 1, 4 plus 1. So right answer should be A. Right answer should be A. Answer should be A. Yep, answer should be A. Clear? Is that understood? Answer should be A. Okay? Chalo. There are certain basic terminologies that we are supposed to be aware of. Whatever is written inside the square bracket, is known as the coordination sphere. Okay, whatever is written, so everything that you try to learn has certain set of vocabulary. If you want to learn Spanish, there are certain words that you should be aware of and how to use them. So the language is dependent on the vocabulary that you are using. If you are doing any kind of programming, then there will be certain set of commands that you have to remember. You cannot deviate from there. So coordination sphere is the coordination sphere is the part represented inside the square bracket. Whatever part is represented inside the square bracket is the coordination sphere. For example, if I write NiCO4, this becomes the coordination sphere. Coordination sphere. Inside the coordination sphere, what do we have? Inside the coordination sphere, what do we have? Inside the coordination, we have the central metal atom. This is the central metal atom. So nickel becomes the central metal atom, CMA. And whatever apart from the metal atom is present is known as ligand. Ligand is something which will bind. Ligand is something which will donate electrons to the central metal atom, or which will form a bond with central metal atom. So anything which is present apart from the central metal atom is known as ligand. Okay, anything present apart from central metal atom is known as ligand. Okay, so if I take this complex, can you tell me that LiAlH4, can you tell me what is the central metal atom? What is the central metal atom? What is the central metal atom? Right? In this, what is the central metal atom? Aluminium. Very good. Aluminium. Okay, I should better write Al3 plus because that is the oxidation state of aluminium. I should better write Al3 plus because that is the oxidation state of aluminium. What is the ligand? What is the ligand? The ligand is what is the ligand? Pahul sir is on a vacation, man. Nobody, he is not being held up anywhere. He is on a vacation. Okay, the ligand is H minus hydride. The ligand, there are 4 hydride units, though not 4H. I will not say ligand as 4H. This is hydride. So ligand is H minus. We will not say that it is H4. Please do remember, anything which is present inside the square bracket apart from the metal is known as ligand. So ligand is H minus. I will not say that 4H. Ligand is just H minus. The number of ligands is 4. Number of ligands is 4. And what will Li be known as? Li be known as the counter ion. Li will be known as the counter ion. Is that clear? Li will be known as the counter ion. Okay, so you can see central metal atom is nickel, cobalt, iron. Okay, central metal atom is nickel, cobalt, iron. Cl and OH will become ligand. Cl will become ligand, NH3 will become ligand, Cn will become ligand. Okay. And what are ligands? Ligands are species which are directly connected to the central metal atom in the coordination entity or the coordination sphere. We will discuss about ligands in tomorrow's class, more about ligands in tomorrow's class, and we'll try to learn more about, we'll take some questions on these basic terminologies. Okay, clear? So chalo, that's all for today, and I hope you have enjoyed today's class. And please do share this video, please do like the video, and please do tell your friends that at 9:30 every day I am coming on the channel to teach coordination chemistry. Okay, so this is Saurav Goswami signing off. I'll have to join the 11th standard class right now. Okay, chalo, bye bye guys, have a lovely time and take care. Bye bye.